Hello everyone. I wanted to share a winter procedure and set of grids I put together that should really make the winter weather forecasting process a lot easier and more efficient. So everything really goes down in the winter weather element group. Here you're starting off in public. To go to winter weather, you go to element groups. Here in alphabetical order of aviation down to winter weather. And then down here is some more individual elements if you ever want to edit them individually. But we'll go into winter weather here. And at the top, you have your base grids like temperature, dew point, pop, and QPF down here. And those are the items you'd obviously want to edit first before running any kind of winter weather tools. Then there's these 7 new grids here. There's weather partial thickness blend down through NAM. And then weather top-down blend down through NAM. Partial thickness grids are run out 8 days potentially. And the weather top-down grids go out about 84 hours. These grids are run on a cron every hour, and they'll also be updated by a selection you make in a procedure I'll talk about shortly. And the crons run differently every hour depending on when a new model run comes in. Then down here, there's 3 different snow amount and isoccune grids, which we'll talk about shortly, that can potentially be useful also in your snow amount and isoccune forecasts. Forecast grids at the bottom show a lot of partial thickness and top-down grids, and these are what we kind of utilized last year via the winter weather tools here at the bottom of the edit menu, and those are still going to be available if you wish to use them, but this new methodology should be a lot more efficient. And for service backup node, these still need to be available as well. Down here, there's snow amount and isoccune for the MBM and the WPC guidance. There's some pot grids from the MBM. And then finally at the bottom, there's a winter storm outlet grids from WPC. So there was really a lot in this winter weather element group. So going back to the public group, I'm going to run this new procedure. It's populate 1lm winter weather. Basically a 3-step procedure, but really there's only one step. That's step 2 that really requires some manual intervention. Step 1, again, you run after updating temperature, dew point, pop, and QPF. It's going to update those 7 model weather grids shown down here, as well as the 3 snow amount isoccune grids. And that's going to take about 2 to 3 minutes to run because it's essentially just updating the wet bulb temperatures, surface warm layer grids as well. For the most part, it occurs pretty fast because a lot of the top-down steps are going to be run when a new model comes in on a cron. So that should save you a ton of time. And then once you go on to step 2, once you're ready for step 2, just make that selection here and then we'll go down here. But for now, I'll just run that and it automatically goes down into the winter weather group and starts updating all these grids. So I'll close out and go down to practice mode to show you an example here. We'll open up the 1lm winter weather procedure again. And you'll know step 1's done running because the text that's shown down here will pretty much go away, and then you know you can go on to step 2 down here. So click the step 2 so it doesn't run that again. Move it down here. And you can run this multiple times per shift. It doesn't matter if the other person isn't done with their temperatures, dew point, pop, or whatnot. You can run this 5 times if you want, whenever you want. But the idea is to run this when you're done with these surface fields, because when the crons ran an hour ago, they might have been using old data. So now that you have your updated temperatures and dew points, you can rerun and get you the latest data available for these grids. So these grids are created if and only if you have snow, freezing rain, or sleet within the 1lm domain. So that's why here you're not seeing a lot, because it's straight rain, and you know right away that I'm probably not expecting winter weather. And down here you can see in this made up example, tomorrow afternoon, I'm getting grids for the top-down method in the blend, GFS, and NAM versions from 18Z to 0Z. In terms of the snow amount grids, ISOQM and FRAM and the From Smart tool, the snow amount from snow ratio QPF grid, basically just multiplying QPF times WPC snow ratio with a further reduction for temperatures above freezing. The FRAM grids are more advanced tool-based that incorporate QPF, pop, weather, wet bulb temperature, and wind. The From Smart tool is a more legacy type tool that takes into account precip rate, QPF, and wind. And these grids are created only if there's values greater than 0 within the domain. So you can know right away looking out in time, oh, I'm probably not expecting any snow amount or ISOQM. But if you do wish to use them, all you have to simply do is right click on the grid and then paste it into the associated forecast grid. So ISOQM would be there. So if I wanted to use a grid from the snow amount from snow ratio QPF, you just copy it and then you paste it right in. And that's really going to be faster than running any kind of procedure, just copying and pasting the grids right in directly above, because typically we're probably only expecting 6 to 12 hours of winter precip anyway. And then you could potentially also use MBM or WPC guidance below. You could just right click on snow amount there and paste it right into your forecast grid. So that's a faster way to do it. And that's pretty much the step 3 down here. It's not really a step, but it's just explaining that to manually copy and paste those grids in if you want. So now going back to the methods here, partial thickness and top down, I'm going to show you how to force these into your weather grids. It's really, really simple. All you have to do is select your time range. Like it says here, select the time range before running. And then say I want to use the weather top-down blend, which is probably one I would probably favor most of the time in the short term. All you have to do is hit run. So it's loading in. There's rain here and then rain, snow up here. Now say WPC discounts the NAM. Say they think the track of the low is too close to the coast, and that's why it's showing all rain everywhere. And you probably just want to favor the GFS then, which is showing a rain-snow mix further south. Again, all you have to do is select the time range and hit weather top-down GFS and run with that. There's also options if you want the intensity to be moderate or heavy. So say I want to make it heavy. And then also if you want RW and SW instead of R and S, you can make it showery. You can also select an area, edit area to run these tools on to make things different. So you can see it updated that. So there's a lot of flexibility, and you can pretty much do everything you need from this one GUI. So just to summarize, there's several advantages to this process. Say you're just coming on shift, and since the grids are run every hour on a cron, you can really know right away if winter weather is possible or not, and then also how much uncertainty there is, because you're going to get data from all the models and techniques, so you can see if there's consistency or not. And again, this will go out 8 days in terms of partial thickness method. Biggest thing is it's going to save a ton of time compared to having to run each individual top-down and partial thickness step, and then having to choose which time range or models to select for each go-around, because it allows you to really easily view and compare all the models and techniques at once with just a click of one button. And it also offers an equal blend option, a 1-to-1-to-1 option that you can take advantage of. Now you might ask why the procedure only takes 2 to 3 minutes to run. In the past, whenever you would run all your top-down steps, it would take sometimes 10 to 20 minutes to do, even over a 6 to 12 hour time period. And that's because I have the model cron set up in a way where all the fields aloft in the top-down methodology are created once the model run comes in. So you're really just updating your wet bulb temperature in your surface warm layer step when you select run here in step 1. And that's why it's only taking a couple minutes to go through. And then the majority of the top-down steps are already done, like I said. And then if you want to view all the individual model grids, you could go to this weather element group cron at the bottom, and that'll show you everything that's being run behind the scenes. I don't have grids here because I'm in practice mode, but these are the items that are run on a cron every hour, and kind of saving you time from when you hit run. The data is already available in the background. So I'm also going to look into utilizing Graph IDSS to save output from the 7 winter weather grids, and also snow and ice tool outputs. So any kind of post-analysis or verification can be done after an event to see which models or techniques perform well. So really, overall, to do your winter weather forecast, all you have to do is pull up the SCUI and hit run, and then do step 2 and 3. It's really going to save you a lot of time, and at the same time, it allows you to pick and choose what model or blender technique you wish to utilize. So please let me know if you have any questions. Thanks.
Okay, Matt.
Yeah, thanks for showing that. I can take any questions on that.